force like overturning the skid effect, how it is happening, to avoid that how the elevations we are providing with respect to the center line as well as the inner or the outer portions of the pavement, and how we are designing the super elevations with the detailed examples problems we have covered in the yesterday class. Today we are going to cover the component widening of pavement. So with this figure, you might be understanding when it is coming to the turning. So when it is coming to the turning, so we have provided the extra widening. So here the bus might be restricted, but when we are seeing in this particular figure, you can able to see how the extra widening we have provided for the various applications. So what is the width of the exact extra widening portions which we provided on the field? What is a role? So those kind of that basic as well as the design oriented knowledge you are going to get it from this particular component. So that's what we have explained here. In a horizontal curve, especially when they are not of very large radius, so the radius might be small 150 meter or the lesser than that, then it is common to widen the pavement slightly more than the normal width. So the radius, we have the restrictions, we have the speed limit also. Other than that, for providing the extra widening, we have the four major reasons. One is the driver is experiencing difficulties in steering around the curve. So we are driving different kind of the vehicle, two-wheeler, bus, truck. So the bigger vehicles also playing the major role. So each and individual drivers are experiencing the different difficulties with respect to the steering and the mechanical component at horizontal curve. To make the better turning of that particular journey, so we are providing the extra widening. Then the second one is that very important one is that off tracking behavior. What it is meaning that the vehicle occupies a greater width as the rear wheel don't track the front wheel. So the front wheel might be occupying, but the same path we are not, and it is not possible to follow the rear wheel. So the extra greater what it is followed by the front, that is not followed by the back wheel. So those kind of that mismatching is considering as an off tracking. So that off tracking behavior is rectified by providing this extra widening. Then definitely it is a visibility, particularly when it is coming to the sudden turning or the curve which is available in the hilly station. Then the main will be there in case in the horizontal curve two directions flows are there, so the vehicle cross each other, or in case some vehicles are taking the overturning, so that time the psychological tendency to maintain a greater clearance between the vehicle for the safety purpose we are providing the horizontal curve. So that is the things we have explained over here. So why we want to provide the pavement extra widening at horizontal curve. So basically when we are explaining little bit more about the off tracking, so the wheels, both side wheels are very rigid, right? Wheel base is very rigid, two wheels will be there. So example, if we are considering the two wheel, it is a very rigid one. Okay, so one way the vehicle is trying to negotiate the horizontal curve. So this is a front vehicle, it is getting the turning, but the same turning it won't follow the your back wheel, right? The same path it won't follow the back wheel. In case if it is following like this, back wheel might be following in this particular direction. So this kind of that mismatch we can say, which means that the real wheel do not follow the exact path what the front wheel followed. So that phenomenon is considering as an off tracking. So this is the things. So the wheel with respect to the wheelbase, rigid wheelbase, maybe the front and back wheel distance might be the L distance with respect to the radius, or how the psychological behavior is affecting. To nullify that psychological effect, the extra widening we are provided on that particular road stretch. So that we are going to study in the little bit elaborated manner. So when it is talking about what we can say the design, so let me explain in the one note. So when it is talking about the designs, the extra widening is divided into the two major part. One is the mechanical widening, the second will be the psychological widening. When we are trying to add the both component together, we come to know what will be the extra widening. So the mechanical widening is required to account for the off tracking. So previously I have explained off tracking, right? The off tracking due to the rigidity of the valve piece. So that we are accounting by providing the mechanical widening. So that is with respect to the first component. The second will be the psychological component. It is completely depending on the driver. So how his ability, the steering with the coming to the high speed and all, what kind of the extra with the psychological to nullify the psychological effect it is needed. So that can be estimated as a psychological widening with. So both with when we are trying to add together, so that is considering as a total widening. So this is a two major component. Let me explain little bit elaborated how can we estimate the mechanical widening. So example you consider, so this is on a front wheel trying to turn and this is on a back wheel. So the rigid wheelbase distance is considering as an L. Okay, as I mentioned that the front wheel is following this particular path. Obviously the back wheel won't follow the same path. So this is the path which the rear wheel used to follow. So the difference between their path is considering as a mechanical widening. That difference we have to provide on the field as an extra payment with. So this WM need to be estimated during the design before implementing the field. So how to estimate this value, that mechanical widening width? So you know your radius. So this is an origin of the radius O point. So this is the distance O to the outer wheel of the rear portions A. So this is considering as an R1. At the same time, the distance between the origin of the your horizontal radius to the outer wheel of the front wheelbase is considering as an R2. And this projections we can consider as an C. So this is considering as an C. Okay. So let me say OA is nothing but R1. So that is the radius. What we can say the outer rear wheel is traveled. OB is nothing but R2. Okay. R is nothing but the radius which we know typically. WM is nothing but the mechanical widening. L is nothing but the length of the wheel base. So this is the things, and we know that OC which means that this to this minus OA when we are trying to provide it. So that is ultimately equal to the OB. So this is a distance OB minus OA. So OB minus this OA. OB is the total length minus OA. So in this particular way, we can explain. So that is nothing but OC is equal to OB. So that's what we are meaning over here. Then OB is nothing but R2. OA is nothing but R1. So R2 minus R1 is nothing but width of the mechanical widening. So this is in a one way the mechanical widening we can able to estimate it, but with this it is very difficult to solve the problem. So what we are considering in the sense we are considering triangle OA and B. So the triangle we were considering O, A and B. So this triangle we were considering. So everybody knows that OA squared is equal to OB square minus BA square. I'm not going to much details about that mathematical part because it is very simple. From the school onwards you might be studied. So OA squared is equal to OB squared minus BA squared, right angle triangle we were considering. So OA is nothing but R1 squared, OB is nothing but R2 squared minus len squared. So this is the things, and we know that R2 minus R1 is equal to Wm, and we can try to estimate what will be the R value, which means that R2 minus R1 is equal to Wm, then R2 minus Wm is nothing but R1. So this value we try to substitute over here. So R1 square is nothing but R2 minus Wm the whole square is equal to R2 square minus L square. In continuation of that, A minus B the whole square, you might be know R2 square minus 2 into R2 Wm plus Wm square equal to R2 square minus L square. So from this you might be estimating the value of the Wm. When finally we are trying to simplify, so you might be getting approximately, we are finalizing Wm is equal to L squared divided by 2 into R. So this is a final equations for the mechanical widening with respect to the length of the wheelbase and the radius. So in case the problems, if they were asking the mechanical widening, so you might be knowing the length of the wheelbase. Basically we are used to assume as a 6 meter. Okay, then the radius might be given in the problem, and when you're trying to apply on the equations you come to know what will be the mechanical widening. So it is relatively simple, the mechanical widening estimations. So the front off tracking phenomena, that means the effect is happening, the rear wheel do not follow the path of the your front wheel, so the changes or that off track distance is considering as an extra widening portion. That extra widening portions we need to provide on the field to nullify that particular effect. So for that, the simple derivations with respect to the theorems we have it derived, and the final equation is the Wm equal to L squared divided by 2R. So this is considering as a mechanical property. And when it is coming to the psychological property, so I'm just directly giving the equations. W psychological widening is equal to V divided by 9.5 into root R. So V is nothing but the design speed of the vehicle, R is nothing but the radius of the curve. So when we are trying to add the mechanical and the psychological widening together, you might be giving the total widening what you want to provide. Okay, so basically the equations what we have a derived L square divided by 2R. So that is for the single lane road. In case if the double lane road, 3-lane road or the 4-lane road, according to that the number of lanes should be counteracted. So that's what we have introduced N here. So N into L square divided by 2R. So in this equations, so the Wm is equal to N into L square divided by 2R. If it is single lane, it is 1. If the 2-lane, it is 2. So according to that, we are defining. So this is in a final equations. Let us solve any one or two problems. So definitely you will be getting the better clarity. So here you can see the problem what they have given. what they have given in the sense, calculate the extra widening required for a pavement of width 7 meter on a horizontal curve with a radius of 200 meter. If the longest wheelbase of vehicle expected on the road is 6.5 meter, then the design speed is considered as an 65 kilometer per hour. So the problem, extra widening they were telling to estimate, so they have not specified mechanical or the psychological widening, so both need to be considered and combined, so that is considering as an extra widening. What are the data given? They have a given the pavement width of the road, so that they have a given as an 7 meter. Why this is given? Because the mechanical widening, the number of the lane is playing as an one of the component. When it is given as a 7 meter, what is the number of lane? Obviously it is in 2, right? So each lane 3.5 meter we are considering. So when it is coming to the 7 meter, then the number of lane is nothing but 2. So the n is equal to 2 is given in the problem. Then the horizontal curve radius is given as an 200 meter, or is equal to 200 meter. Then the wheelbase is expected on the length they have given as a 6.5 meter. If not given in your problem, you assume the L value as a 6 meter as per the IRC standard. Okay. If not given in the problem, most of the competitive exam they won't give. So you have to assume length is nothing but the 6 meter. Then the design speed V is equal to 65 kilometer per hour. So this is the detail is given in the problem. They were asking the extra widening width. Extra widening width, it is considering as a mechanical widening plus psychological widening, right? So mechanical widening is nothing but Wm plus psychological, which we have denoted as an W into PS. Then the simple equations, what we have derived, N into L square divided by 2 into R plus V divided by 9.5 into R. So N is nothing but 2-lane road, length is nothing but 6.5 meters square divided by 2 into radius is 200 meter plus what is that? V is nothing but the design speed 65 they have a given 9.5. What is the R value? 200. If you are putting square root, so you come to know the 2 value. When you are trying to add the both value, you will get the final extra widening width. So can you people estimate the value? So 2 into 6.5 square divided by 2 divided by 200. I'm just getting the value of 0.21125. So I'm taking as an 0.21 plus 65 divided by 9.5 divided by root of 200. So I'm getting the value of 0.4838. So I'm making 0.48. So 0.21 plus 0.48. The final value I am getting the 0.69 meter. So this is the extra width we have to provide. So basically this is in a horizontal curve. It is coming. Okay. So in that horizontal turning, basically the width is given as a 7 meter. So other than the 7 meter, we are providing 0.69 meter. So the new width is extracted with respect to the this extra widening 0.9 meter. So overall the width at the horizontal curve is nothing but 7.69 meter. So this is we are following on the field. So this is in a one the simple problem, little bit extra effort if you want to put in the particular problem. So let us focus on the second one. Find the total width of the pavement of two-lane road on the horizontal curve for a new national highway to be aligned along a rolling terrain with a ruling minimum radius having a ruling design speed of 80 km per hour. Assume all necessary data as per IRC standard. So what they were telling in the sense, so we have to estimate the radius. The radius what they have mentioned in the sense ruling minimum radius. So this is what they have a mean it. Let me discuss what they have given in the problem first. They have given two-lane road. So n is nothing but 2. Other than that, what they have given the design speed, they have given 80 kilometer per hour. Since it is on a two-lane road, what will be the width of the road? W is equal to 7 meter. So this is the width of the road which is already given in the problem. Then assume other data. What are the other data you need? L is required, right? The wheelbase distance. As I told that L we need to assume as an 6 meter. Then they were telling that to assume and estimate the radius, ruling minimum radius they were telling to estimate by considering the rolling terrain in the highway. So they were telling that highway. So this is the statement they have given in the problem. So how to estimate the radius? As you know that the simple equation is super elevations. Previously we have seen E plus F is equal to V squared divided by 127 into R. So this R is we are going to estimate from this particular equation. But we don't know any value of E and F. But I told that as per the IRC, the allowable E value is nothing but 0.07. Then the lateral friction's coefficient is nothing but 0.15. B square is nothing but 80 square divided by 127 into R. So from this equations, you can able to estimate what will be the R value. So 80 square divided by 127 divided by 0.07 plus 0.15. I am getting the value of 229.06227. So I'm just assuming the value of 229, not assuming, I'm just fixing the radius of 229 meter. So this is the things you have to estimate from the given problem. And now our duty is to estimate the extra widening. So extra widening is nothing but mechanical widening plus psychological widening. The equations for the mechanical widening is n into L square divided by 2 into R. Then the psychological widening is nothing but speed divided by 9.5 into root R. N is nothing but 2. It is given in the problem, 2-lane road. L is not given in the problem, but previously I told we have to assume 6. So 6 divided by 2 into R. They are estimating the ruling minimum radius that is given as an 229 meter. Plus V is nothing but the design speed 80. It is given in the problem divided by 9.5 Yeah, 229 root. So estimate the value 2 into 6 square divided by 2 divided by 229. I'm getting 0.1572. So I'm fixing the value of 0.157 plus 80 divided by 9.5 divided by root of 229, and the value I'm getting is 0.55647. So I'm just to make it as 0.557. So when adding this two value 0.157 plus 0.557, 0.714 meter. So this is an extra widening we have to provide on the field, but the question is not the extra widening, to find the total width of the pavement. So the total width of the pavement is nothing but the width is 7 meter because it is in a two lane. So W plus WE, total pavement width. So 7 meter plus 0.714. So 7.714 meter is the final results. So this is a total width of the pavement which we are providing on the horizontal curve by considering the mechanical as well as the psychological behavior with respect to the Indian Road Congress standard. So this is in a complete details about that extra widening. Any doubt, student? So this is the another component in your horizontal curve, followed by the super elevations, widening of the pavement. The next will be the transitions curve. Probably we will discuss in the next week class. Then we try to cover the vertical alignment as less possible. So another two major components is there, remaining of your second unit, highway geometric design. So in the today class, we have started that another component, extra widening. Extra widening, basically we are providing for the four major reason. So that reasons we have discussed, particularly when it is coming to that extra widening design estimations, we try to understand the off tracking effect. So to nullify that off tracking effect, the mechanical widening is introduced. The simple derivations we have seen as an your syllabus component. So once we understand that mechanical widening, the formula for the psychological widening directly given. So using this both value, how to design. So with respect to the two simple problem we have discussed, so there is a scope. Sometimes they might be asking the mechanical or the psychological, what we can say widening, probably estimating that radius by yourself, and moreover the super elevations coefficients of the frictions we have assumed, but sometimes they might be giving the criteria. So with respect to the criteria, the four step super elevations designs you have to follow it. So once you know that the super elevations and the coefficients of the frictions that can be applied, followed by you have to estimate the widening, extra widening. So the link is there between the one component to the another component. How the question is existing, read it, understand what the component is given and what criteria they have explained in that particular problem, that you try to understand, then according to that you try to solve that particular equation. So this is the way we can expect the questions in your competitive exam, and it is definitely it will be there, but we are not sure from which portions it might be coming the question from the second unit. So here I'm concluding that today's session. Next week we can start our the next component, transition curve and the vertical alignment. Any doubts, students? if there is a no doubt, there is a two way. One is whatever I'm teaching, you are clear crystal manner, you are getting all the inputs, but I don't know how much it is truth. The second way is nothing but you are not at all getting anything. That is the reasons there is a no questions. Either this or that only the possible. Which way I have take? Ayush Shukla, Ayush Shukla, are you there? In case your audio is not working, you just post it in message. Okay. Dheeraj, Dheeraj Reddy. Dheeraj Reddy, Dinesh Kumar.
Yes, sir.
So how the classes are going on in my subject? I'm just asking whether will you able to follow it or any pattern. Do you want to change it?
No, sir, it's fine, sir.
You are understanding everything. No, I'm not
Yes,
going to
sir.
ask question. I'm just asking, checking if the pattern. If you want to change it, we can change it a little bit slow, or whether we are moving fast.
No, sir, it's fine, sir. It's good, sir.
Okay.
Sir, and a
Jayesh.
small doubt, sir.
Yes,
Sir,
please.
what is the significance of the using rolling terrain in that, sir?
What is the significance of?
Using that rolling terrain term in this question, sir.
So actually, initially, if you remember that, I have a given different kind of the super elevations criteria. If the plain and rolling terrain is there, 7% is maximum allowable. Then the hilly road is there. So what will be this? So that classification is given. So according to that, we are finalizing E value as an 0.07.
Okay,
If
sir.
the hilly station is the 10 percentage we are providing, that criteria we have covered in the previous class.
Yes, sir.
Okay. Jayashree,
Yes, sir.
so what is the comments from your side?
Sir, everything is fine, sir. The way you teach PPTs, everything is okay, sir.
Okay. Prakash, see, people are telling something, then only I can able to change it. Still, we have that few components in the second unit, and the third unit also very lengthy unit. So much traffic component we are going to study. But there little bit problem is there, but mostly the practical as well as that traffic related research interesting components also I can incorporate in the third unit. But the second unit little bit lengthy, including the problems. I'm damn sure you will be getting the two questions or the minimum one questions in your competitive exam. So understand all the term. Since it is an online classes, I know how your people are performing the exams. For the longer term, it will get affect. So kindly spend a lot of time. You must go through the second unit very detailed. If you're not believing my word, you just google it. You previous gate exam or the IES exam or SSC exams, you have to see the questions paper, then you will be understanding what I'm trying to mean it. So understand all the components, try to learn and understand all the equations including the terms and the units. If it is not possible, the worst case you have to mug it, and definitely the questions will be there. Okay, for your competitive exam. So not only you focus on your institute level exam, outside also it is required. Since it is a one T1 and T2, T1 the highly expected questions will be there. That too from the second unit. Okay, so if everything is going well, then I'm happy about it. We will follow the same patch, same pattern, the way of teaching for the remaining second unit as well as the third unit. And stay safe, take care. We will see in the next week. Thank you, everyone.
Thank you, sir.
Yeah, the one more thing, I'm feeling very bad actually. Whenever I'm saying the good morning, I'm feeling the very getting very less response. When I'm saying the thank you, I'm getting one or two response. I don't know whether you people are active or not, but still, you maintain that. Okay. So thank you everyone. I'm ending the session.
Thank you, sir.
Yes, sir.